All right, next up, we're going to look at center of mass in 3 dimensions. So if we suppose we have a 3-dimensional solid now, and we would like to measure its center of mass, well, we are now looking at 3 spatial coordinates. So in turn, we're going to look at 3 moments. So we, again, will just first start out by partitioning our solid into a bunch of little boxes now. And if the boxes are sufficiently small, you can think about the mass of that little box as being concentrated at some point in the box, and we'll label that sample point, xi star, yj star, zk star. And then from that, well, I can measure the following 3 moments, okay? So I can measure the moment of this point out here about the yz plane. Okay, so that's going to be what? It's going to be the mass of our box, which will be the density times a little change in volume here. So density times volume is the mass times the distance from this point to the YZ plane. And notice that that distance is given by this location's x coordinate. So when we go ahead and uh, sum over the region and then take the limit to get this integral, okay, we're going to wind up getting x times the density function for this moment about the yz plane. And then likewise for these other 2 moments, the moment about the xz plane, we're going to integrate y times the density function over the region E. And then the moment about the xy plane, this is going to be the integral of z times the density there, okay? And then for the center of mass, well, we're just going to take these respective moments and divide them by the total mass of the system, and that will give you the coordinates of your center of mass. And in the next couple examples, we will illustrate all of this with some computations. All right, thanks.